Hurricane Melissa has been absolutely historic.
The hurricane hunters have been in and out of this storm getting very crucial data.
Hurricane Melissa is now a powerful Category 5 storm.
This is probably one of the strongest hurricanes that's ever hit there, so I'm very, very fearful for the people there.
The entire Jamaica has felt the brunt of Melissa.
Major Hurricane Melissa, a storm that will be studied for years, not just for how strong it became, but for how well it was predicted and what it taught us about the future of high-impact hurricanes. Following a detailed postseason analysis that came out on February 25th, 2026, the National Hurricane Center confirmed that Hurricane Melissa tied Hurricane Allen in 1980 as the strongest Atlantic hurricane ever recorded by maximum sustained wind speeds at 190 miles per hour. This confirmation did not happen in real time because intensity estimates are refined after the season ends. Scientists reanalyze aircraft reconnaissance data, dropsonde measurements, satellite imagery, radar trends, and surface observations. They also reassess the pressure-wind relationships using updated calibration techniques. In Melissa's case, the review confirmed peak winds of 165 knots, officially tying the Atlantic record. With that context established, we can step back and look at the storm more comprehensively. Melissa ultimately became one of the most intense hurricanes ever observed in the Atlantic Basin, reaching a minimum central pressure of 892 millibars along its 190 mile per hour winds. Despite its eventual historic intensity, Melissa originated from a typical disorganized tropical system that struggled to originally intensify. The system became a tropical wave off the west coast of Africa in mid-October 2025. As it moved into the Caribbean, it initially encountered moderate wind shear that limited development. Once the shear relaxed and the storm tracked over sea surface temperatures between 86 and 88 degrees Fahrenheit with ocean heat content, environmental conditions became highly favorable for rapid intensification. Then the response from the storm was explosive. Within 24 hours, Melissa strengthened by 45 knots. Over the following days, it intensified from a tropical storm into a Category 5 hurricane just south of Jamaica. On October 28th, Melissa made landfall in western Jamaica as a 160-knot Category 5 hurricane. That landfall made it the strongest hurricane on record to strike Jamaica and tied it for the strongest landfall in Atlantic history based on wind speed alone. While the wind intensity was historic, the hydrological impacts were equally significant. Melissa's slow forward movement allowed persistent rain bands to repeatedly move over the same area. Southern Haiti recorded more than 35 inches of rainfall, while parts of Jamaica exceeded 30 inches of rainfall. The combination of extreme rainfall and mountainous terrain led to widespread flooding as well as landslides. Storm surge along southwestern Jamaica was estimated between 7 and 11 feet above ground level, enhanced by destructive wave action. The economic consequences reflected the scale of the event. Damage in Jamaica was estimated at $8.8 billion, which is equivalent to roughly 40% of the country's gross domestic product. In practical terms, that represents nearly half of the total annual value of goods and services produced nationwide, including infrastructure, housing, tourism assets, agriculture, and energy systems. After crossing Jamaica, Melissa weakened to a Category 3 hurricane before striking eastern Cuba. It later moved through the southeastern Bahamas and eventually transitioned to an extratropical cyclone near Bermuda. In total, the storm resulted in at least 95 fatalities across multiple countries and caused billions of dollars in damage. From a meteorological perspective, one of the most notable aspects of Melissa was the forecast performance. Several days before landfall, while Melissa was still a tropical storm, the National Hurricane Center forecast indicated the likelihood of rapid intensification and projected a major hurricane approaching western Jamaica. Approximately 3 days prior to landfall, forecasts explicitly showed the potential for Category 5 intensity. These projections did end up verifying. Rapid intensification has historically been one of the most challenging processes to predict due to its sensitivity to small-scale changes in atmospheric and oceanic conditions. In Melissa's case, improved satellite diagnostics, enhanced ocean heat content analysis, hurricane-specific dynamical models such as the hurricane analysis and forecast systems, and refined data assimilation techniques contributed to increased forecast confidence. The storm also reinforced the importance of track precision in rainfall forecasting. Even minor deviations in motion significantly influence rainfall distribution and flood severity. Taken together, Melissa represents more than a record-tying hurricane. It demonstrates measurable progress in forecasting rapid intensification, highlights the compound risk of wind, surge, and rainfall, and underscores the vulnerability of small island nations to extreme events. Melissa will be studied for years, not only for its intensity, but for what it revealed about the evolving science of hurricane prediction and the importance of communicating high-impact risk effectively.